Hello everybody, welcome to our first session of online Algebra 2. This is Mrs. Heinz, of course, and today we're going to kind of pick back up where we left off before school let out in chapter 11 of the algebra textbook. So we had gotten through lesson 11.1, spent 2 days on that when we were still physically in the classroom. And then over the last couple of weeks, you guys spent a little bit more time practicing those skills in terms of how to simplify radical expressions. So some of you may want to go back and just review the notes in your note packets. Hopefully you have those with you. If not, I did post those on our website. You can just download, print those off. And if you don't have a printer, you can at least refer to those as we go through these notes and just kind of jot them down on your own paper. So today we are going to talk a little bit about lesson 11.2, specifically the first objective, which is how to simplify sums and differences of radicals. So first of all, for us to be able to either add, which is what sum is referring to, or subtract, or find the difference between two radical expressions, we have to know whether or not they are like radicals. So I kind of like to compare this back to fractions. When we want to add or subtract fractions, we have to have common denominators. For us to be able to add or subtract radicals, they must have a common radicand. So when we talk about radicals being like radicals are radicals with a common radicand. And technically speaking, you'd also want to say also they have the same root, but we are only dealing with square roots. We're just kind of going to gloss over that part of it. And then of course, if those are like radicals, then unlike radicals are radicals that do not have a common radicand. And just to kind of refresh your memory, when we talk about radicand, this is a radical, and then whatever is underneath of it, so you might have like 24, let's say. 24 would be the radicand of this radical term. So an example that I could give you right now for two radicals that would be considered like radicals would be root 2 and root 2. They both have a 2 for their radicand. And then an example of two radicals that are not like radicals would be maybe like your root 2 and then your root 3, because they have different radicands. So I could add or subtract those two together, whereas down here I could not. Now something that we're going to come across quite a bit is situations where maybe we've got like root 2 and I'm just going to say and for now, root 8. At first glance, you look at that and say, nope, those are not like radicals because the radicands are different. This has a radicand of 2, this one 8. However, learning or remembering what we learned back in lesson 11.1, we know that root 8 can actually be simplified. This is not in what's considered to be simplest radical form, whereas root 2 is. So when I look at 8, I think of a way that I maybe could break 8 down into a perfect square times a non-perfect square. So I would think of this or rethink of this as the square root of 4 times 2, which then allows me to individually, using that product property of radicals, break those apart. And then I can simplify the square root of 4 because 4 is a perfect square. So this is like 2 square roots of 2. And if I bring down the original, root 2, now, when I look at those two radical terms, I would say, yes, those are like radicals because they both have a radicand of 2 when they are both in their simplest form. And then I could say, well, what is that plus that? Well, I've got 1 of them here, and I've got 2 of them there, so I would say that I have a total of 3 square roots of 2. So notice that when I added those, I did not say square roots of 4. Just like, again, comparing back to fractions, if you had 1/7 plus 2/7, those do have a common denominator. And when you add them, you'd say 1 plus 2 would give me 3/7, not 3/14. So it is kind of easy to compare it back to adding and subtracting fractions. Here we had the common denominator, we just added the numerators. Here we finally achieved a common radicand, and then all we have to do to add those is just take the coefficients on those root 2's, combine them. So 1 plus the 2 in front will give us the 3. The radicand does not change, just like the denominator up here did not change. So let's just try a couple more examples in the packet. Starting on this one. So it says simplify the expression. I know it's kind of blurry. It says negative 3 root 5 minus 4 square root of 5. So right away I notice these are like radicals because they both have a radicand of 5, and even better, 5 cannot be broken down. The only factors of 5 are 1 and 5. And if we broke it down that way, it would still just be root 5. So all I've got to do here is I've got to take the numbers out in front, or the coefficients on these radicals, and I'm going to subtract them from the left to the right, because of course subtraction is not commutative. So if I say it out loud to myself, I'm really doing negative 3 minus 4. You could even write that down in parentheses, negative 3 minus 4 more, and then that's how many square roots of 5 you will end up with. So if you do some quick mental math, you're already at negative 3 and you're taking 4 more away from that, so that's going to put you at negative 7 square roots of 5, and that is in simplest radical form, so that would be your answer. Let's come over to this one. Square root of 10 minus 5 square root of 10. Again, right away I notice common radicand. And then when I think of the factors of 10, 1 and 10, 2 and 5, neither of those combinations would allow me to simplify it any further. So this is about as easy as it can get. You take the coefficients in front. So here I'm doing a 1 minus a 5. So I'll throw that in parentheses. And that is how many square roots of 10 that I'm going to end up with when this is all said and done. So if I do 1 minus 5, I get negative 4 square roots of 10. And that again is in simplest radical form because 10 cannot be broken down any further. So that'd be your final answer there. So that's the first kind of situation you might find yourself in, where you already have a matching radicand and it can't be broken down any further. So you just simply take the coefficients out in front and combine them using whichever operation the problem has. So in this case, we did 2 subtraction problems. All right, down here, this is where you're going to have to do a little bit more work up front. We have 8 square roots of 5, and we're supposed to take away the square root of 45. So at first glance, I would say that those two terms don't appear to be like radicals because one, or the first one, has a radicand of 5. That's got a radicand of 45. So I'm going to have to see if I can do a little bit of work with one or both of those radicands so that maybe I can eventually subtract. So kind of just like with example 1a above, I know that root 5 can't be simplified, so I'm just going to simply bring down that first term, 8 square root of 5. And then from that, I will be subtracting, and let's think about 45. When I think of that in my mind, I think 9 times 5 is 45. So I'm going to rewrite that as root 9 times root 5. So that's kind of like the breaking down process back from lesson 11.1. And then what that does for me is I can then say, well, now I'm just being asked to take 8 square roots of 5 and subtract 3 square roots of 5. So now with this second term in its simplest radical form, I do have a common radicand, therefore I can go ahead now and subtract. So if I do kind of the same thing I did above and put the coefficients in parentheses, I'm doing 8 minus a 3. That is how many square roots of 5 I'm going to end up with, and under the 8 minus 3 is 5, so I end up with 5 square roots of 5. That would be my final answer. I think we'll just do one more. Call it good here. You guys can go practice a little bit on your own using the different options that I have on our calendar. So let's come down here and take a look at, we've already seen 5 a couple of times. Let's do this one. 3 square roots of 3 minus 2 square roots of 27. Again, initially, no, they don't match. I know that I can't do anything with 3 because the only factors of 3 are 1 and 3. That would not allow me to simplify that any further. However, I'm going to bring down the minus 2. 27, I know, is the same thing as the square root of 9 times the square root of 3. 3 times 9 is 27, and 9 is a perfect square. So I'm going to be able to simplify or evaluate that radical in my head. So what we would do at this point would be take 3 square roots of 3, and then you're going to subtract 2 times 3 times the square root of 3. And then from there, you would bring this over here. You'd still have your 3 square root 3 minus, and now you've got to take those 2 coefficients that are out in front of that root 3 and multiply them. That minus 2 was already there, and the 3 that came from the square root of 9 will then need to be multiplied by that, because initially 2 up here was being multiplied by the square root of 27. So we all know that negative 2 times 3 would give us a negative 6, so minus 6 square roots of 3. And then now that I've simplified that second term, I have a matching radical, or radicand. So I can go ahead and say in front, I'm taking 3 minus 6, and that will be how many square roots of 3 I end up with. 3 minus 6 is negative 3, so I get negative 3 square roots of 3.